In this example, we're going to look at constructing utility function for Mr. Jones here on the interval from negative 1,000 to 1,000. And so we're going to construct a utility function for additional money. There's two ways we could look at this. We could look at constructing a utility function for a person in terms of their total fortune, their total wealth, or we can look at it in terms of constructing a utility function for additional money that they may earn. That can change dramatically for a person who, say, has $500 in the bank as opposed to one who has $500,000 in the bank. So just to get a feel for Mr. Jones's financial position in life, we're going to assume that he makes $10,000 a year and has $500 in the bank. So first, we're going to look at the reward, and in this case, the reward is monetary reward. So if the reward R is between $0 and $1,000, let's start by saying we're going to set U of 0 equal to 0 and U of 1,000 equal to 1. So we've got to find a starting point. So we're going to say that Mr. Jones values no extra money, none at all. And we're going to set the value of $1,000 at 1. And then everything else will be relative to those 2 points. So the first, after we set those first two numbers, what we're going to do is we're going to pick a reward R1. Well, Mr. Jones would pick a monetary reward strictly between $0 and $1,000. And it has to have the property that Mr. Jones would value this amount of money exactly the same as he would value a 50-50 gamble between $0 and $1,000. So the way to think about that is, suppose Mr. Jones had a lottery ticket, and that lottery ticket will pay $1,000 with probability 1/2. So he could go to the lottery place and they'll flip a coin, a fair coin, and if it lands on heads, he gets $1,000. If it lands on tails, he gets nothing. And the way to think about that is, how much would he sell the ticket for? So if he had that ticket and he didn't want to go play it, he just wanted to sell it, how much money would he sell it for? Because that's his estimated value for that gamble. And whatever that amount of money is, that's what R1 is. So let's say that Mr. Jones chooses R1 equal to 300. So to Mr. Jones, that ticket is worth $300. I mean, if he could just sell it for $300, he would take the money and then let whoever play it or whatever they want to do with it. So this means that the utility that he assigns to 300 is 1/2. Because he deemed it to be exactly the same as this probability distribution on the reward space earlier, which under that probability distribution, which this one was called P2, the gamble, if you will, and the sure amount of money, which he chose to be 300, that's probability distribution P1. And so the expected value of this utility function should be exactly the same under those two probability distributions. And for that reason, U of 300 is equal to 1/2. So now we've got the utility for 3 points. Let's pick 2 more. So first of all, let's pick an R2 between 0 and 300 and ask the same question. What value would Mr. Jones place on this gamble of winning $300 with probability 1/2? And then also, we also need Mr. Jones to answer the question, okay, so what if you had a 50% chance of winning $300 versus a 50% chance of winning $1,000? How much money would it take for you to say, well, I value that gamble exactly the same as, and then whatever number he chooses, that's going to be R3. So let's say that he's chosen R2 to be 100 and R3 to be 500. At this point, it would be a good idea to do a consistency check. So let's first note in this table all of the utility values that Mr. Jones has delineated at this point. And so in order to do a consistency check, Mr. Jones asks himself, okay, what reward would he value the same as a 50-50 gamble of $100 and $500? So you see here that a lot of constructing this utility function involves, Mr. Jones in this case, or whoever's constructing this function, asking how much do they value these 50-50 gambles. And then that'll help to set the utility, between those 2 points. And eventually we'll have enough sort of hinge points that we can put together a curve. And so let's say Mr. Jones decides that he values this 50-50 gamble of $100 versus $500 the same as if he was just going to receive $250 for sure. So he would value either one of those exactly the same. So then the question is that consistent with what we already have? So I would encourage you to take a moment and think about that. In order to answer that question, we first need to calculate the expected utility of this 50-50 gamble. Then we can see, does that seem like that would be the same as the utility that Mr. Jones would like to place on the reward 250? And as it turns out, 250 is inconsistent because like I said, if we first calculate the expected utility of this 50-50 gamble, then what we're going to see is that it's equal to the utility that he placed on $300. So just look at the right side first. So with this 50-50 gamble, we have a 1/2 chance of getting a utility of 0.25, right? That's U of 100, plus a 1/2 chance of getting a utility of 0.75, that's U of 500. And then if you do that calculation, you should see that that's equal to 0.5. But we already have a reward that gives a utility of 0.5, and that's 300. So that's why it's inconsistent with this, what Mr. Jones decided here. And so at this point, he would just need to go back and readjust things. So let's just say that he eventually makes some adjustments and arrives at this consistent set of utilities. And so now that we have a sufficient number of what I call hinge points on the interval from 0 to 1,000, then we've essentially got our utility function on that interval because we can connect the dots. Usually, if you have enough hinge points, you can just connect them with line segments. But, of course, there are smoother options you could take there. So at this point, you would just connect the dots somehow. All right, so the next part is, what about rewards that are negative? What about losing $500, the interval where he loses $500 to the interval 0, to the value 0? So in order to get a start with this, let's compare negative 500, 0, and 500. And the question we want to ask ourselves is, what value, what probability little p would satisfy this equation here? In other words, so let's consider first the probability distribution where Mr. Jones receives no gain and no loss with probability 1 for sure. And then compare that to a gamble where he loses $500 with some probability or gains $500 with some probability. The question is, and again, this all depends on what this person, in this case Mr. Jones, decides. So what probability, right? Obviously that little p is going to have to be less than a half, right? Because in order for a reasonable individual to value this gamble on the right side, it would need to be weighted a little more towards the positive gain side. So the question is, essentially, with what probability would Mr. Jones be satisfied of receiving $500 versus losing $500, and count that to be exactly the same as if he just wins or loses nothing with probability 1. And so let's say that Mr. Jones chooses P equals 1/3. That means that if Mr. Jones could win $500 with probability 2/3, or possibly lose $500 with probability 1/3, then he would count that to be the same as if he just didn't win anything or lose anything. So he would just as quickly take that gamble as to just do nothing. Now, having made that choice for little p, now Mr. Jones can calculate the utility associated with negative 500. Let's see how that works. So remember that Mr. Jones weighted the occurrence of doing nothing and receiving no gain or loss to be the same as this gamble, as long as the little p value is correct. And so this expected value of the utility function should be equal to 0 according to that distribution. So now we know the utility at 500, and we're trying to determine the utility at negative 500. So it's just a question of solving for the unknown at that point, since all of this is equal to 0. Okay, so using similarly discussed techniques, Mr. Jones decides that negative 200 for sure is the same as this 50-50 gamble of losing $500. And then perhaps we could choose 1 or 2 more hinge points and then finally put together a curve for the set of rewards from negative 500 to 0. And then the last part is to put together the portion of the utility corresponding to rewards between negative $1,000 and negative 500. And so at this point, it's just a question of doing similar things that we've done before. So here you see, now we would ask Mr. Jones what value little q would he require so that, okay, so we're going to compare that to the occurrence of losing $500. Let's say of losing $500 for sure. How would he value that? Like, what value of little q would he require in order to value this 50-50 gamble of losing $1,000 the same as the occurrence of losing $500? And so we're going to assume here that he chose q equal 1/3. So he would consider a 1/3 probability of losing $1,000 versus a 2/3 probability of losing nothing to be the same as the situation where he loses $500 for sure. And again, this all depends on the person, in this case, Mr. Jones. And so once you choose that value of q, then using methods similar to earlier, we can determine the utility at negative 1,000. And then at this point, a consistency check might also be in order. And so let's say that he's done that, and here you see Mr. Jones's utility curve.